Hey everyone, I hope everyone is doing wonderful as always. Today let's solve this question from LeetCode, which is merge sorted array. So this is easy level question and then we will derive a solution from this problem. So before actually hopping into the solution, we want to read the question more carefully and then understand the question itself before actually writing the solution so that it's easier for you all to understand what am I saying. Right. So we are given two integer arrays, which is nums1 and nums2. It's here in the function, which is a void merge, and then it's given nums1 and nums2. Two arrays are given, which are both sorted in non-decreasing order. And this non-decreasing order is basically a fancy way of saying your both arrays are sorted. And then two integers are also given, which are m and end. Both represents the size of m. Size of nums, sorry, m represents the size of nums1 and then n represents the size of nums2. Now your task is to merge nums1 and nums2 into a single array sorted in non-decreasing order, which is basically saying sort both the arrays. I mean, both of the arrays are already sorted. We just merge the array and it has to be sorted. Now it's saying the final sorted array should not be returned by the function, which is a void, right? Void doesn't return anything. So, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus 1, where the first m elements denote the elements that should be merged. Okay, so if you see it here in this example, it's saying we have to basically merge our nums2 in nums1, and it has to be sorted in nums1 array. It's saying we don't have to use any extra space in order to store that answer. The extra space is already given in the form of m plus n. So nums1 has a size of virtual size, we can say virtual size of m plus n, but basically it has just a size of m. Just to accommodate that, we merge it into norms1 array. They have given these last two numbers, which is 0 0 0, which is basically the size of norms2. So these 2 5 and 6 supposed to be here, but we don't know where, so we will be merging accordingly. That's the idea basically. So let's jump over to the solution. This is pretty easy solution. I'll give you all a two-pointer approach to solve this problem. So let me write it down here. So it's basically going to be two-pointer APPROACS, two-pointer approach. So now what do I mean by two-pointer approach? Basically, when someone says two-pointer approach, you will be assigning two integer variables. For now, I'm gonna show you all something here. If you simply compare this last element with this last element, you have to compare the elements from your last. You will compare 3 and 6, and then whichever is larger, you will store it in here, right? I'm just showing you all like the basic idea. I'm not exactly deriving the solution here. And after that, if you pass this element here, if you move this element here, your pointer will move here. Next time your pointer will move to 5, and you will again compare your 5 with 3. This pointer hasn't moved anywhere, and since 5 is larger, you will again move your 5 here, right? And then move your pointer to 2. Now you will compare 2 to 3. This time your 3 is larger than 2, then you will store your 3 here, and your pointer will be moved to 2, right? Now you will compare. You will compare both 2 and 2 again, because wherever the pointer lies, you will compare the element on that specific section. Since both of the elements are equal, you can either pass like both of the either you can pass whichever value you want to pass in this particular index. It's going to be this index, right? So I'm just going to pass my this 2 value, which is going to be here. Now I'm going to move this pointer. I will again compare 1 with 2. Since 2 is larger, this 2 will come again here, and then this pointer will be moved out. This pointer, I mean, this will exceed. Basically, I was pointing here at last element. This is second last. This is the third last, right? Now I don't have anywhere to point, so this will go exit from the loop, and then I will have my pointer remaining here, since the element in the norms1 is already sorted, so I don't have to do anything at that point, right? Okay, that's basically the idea. So how would you approach this kind of problem, and how would you convert this actual problem, this understanding, into a code? Well, it's pretty simple and easy. Let me show you here. Initially, since m is the size of norms1 and then n is the size of this norms2 array, you can simply do one thing. Initially assign your one variable which is going to be index, and then add both the size m and n. So just so initially add both values m plus n to come up with the size of norms1. Now you will have two pointers, which is basically one pointer will point here, one of the pointer will point here, and then you will say that is I. So your integer I value is going to be, what is this value? Well, this value is basically m minus 1, right? M is 3, and then minus 1 is going to be 2. So 0 1 2, that's your array indexing. So that's gonna be, I is gonna be m minus 1. Same goes for j. Your j value is going to be n minus 1, which is basically pointing to the end of the array. Since j's element has n values, so to access the last pointer you have to do n minus 1. Now I also said that our element will be started from the last pointer of our norms1. So to track that, we have to have another variable which is going to be index, and then, oh sorry, I already assigned that, right? My bad, I already did that, it's right here. So m plus n is giving you m was 3 and then n is 3, right? It's giving you 6. But the array's size is 6, but to access the pointer you have to do 0, 1, 2, 3, 4, and 5. So you have to decrease -1 from there. Now you will use one loop. You will use one loop which is going to be while your I value is greater than equal to 0 and your j value is greater than equal to 0. If this is true, you will do something here. Now why did I write this particular loop? Well, the reason I wrote that loop is pretty simple here. Initially I said that your pointers will be pointed to the last of the elements I and j, right? And then you are repeatedly comparing 6 with 3. Whichever is greater, the element will go here, and then your pointer will be moved. Your pointer will be moved like that. And remember, when the value of j went outbound, it is basically negative, right? So whenever it's whichever value goes to negative, we don't want to continue our loop. That basically shows that one of the elements value has already been moved to this particular array. So we won't want our loop to run after that particular point. All right, inside that you will compare if your norms1, which is basically this array. Let me write it down here too. uh it is so difficult to understand like that. Okay, let me write that down here. So basically we have norms1 is going to be 1 2 3 0 0 and 0, right? Now what is norms2? Norms2 is basically, I think it's 2 5 6. Let me see. Yeah, it's 2 5 and 6. That's our array. Now we are saying, while our norms1's I value, it is pointing here, j is here, I is there, while norms1's I is greater than equal to norms2 of j, which is basically saying if my norms1's element, last element, is greater than norms6 last element, I'm gonna say that norms1 of index, since we have to basically pass our element into norms1 itself, and then index is pointing here, index is there, norms1 of index is going to be norms1 of I, right? If that's the case, we will decrease our pointer, since the this element, if this would have been larger than 6, then this element has already moved here. Now our pointer will move to the other section in order to get the other element. And we also have to move this index pointer here, so we will do idx minus minus. If that's not the case, we have else condition, right? If that's not the case, we will simply do noms2, oh sorry, it's going to be noms1, noms1 of index, which is basically uh, I'm going to show it here. So, sorry, quickly I'll just write down. Noms1 of index is going to be at this time noms2 of j value. Basically the value j, which was 6, right? Which was 6 here. This is passing, this is going there, I'd say. And then I will decrease my value of index to be idx minus minus. And then also I will decrease my value with 1 j minus minus. Now this loop has been successfully submitted. Now there's one else case that we need to handle. Basically, let's say you have an array like this, which is 1, 2, 3, and then 0, 0, 0 to store any other elements. This is one array. And then let's say your another array was like that, 2, 5, and 6. Initially, your index pointer, let me write with the other pen. Your index pointer is here. Your I pointer is here. Your j pointer is here. Since 6 is greater than 3, you will move 6 here, and then your j value will be here next time. This will be this will go away. Now this index will also move here to have another element, and then you will compare again your 3 with 5. Basically the j value is still larger, so 5 will move here, and then j will move here, idx will also move there, right? Now we'll again compare 3 with 2. Since 3 is larger element, so 3 will go here instead, and then your I value finally moved to there. Now j has already, j is still in the same scenario. Now 2 and 2 will be compared. Since it's like equal element, so we can move our pointer to here and then pass these two or these two here, right here, it doesn't matter. Now so no, we just pass it here, that's why we moved our I value here. Now we will again compare 1 with 2, right? So I is here, j is there, which is larger element, 2 is larger element, so we will pass our, I think the pointer was here, sorry, and then it moved here. Now the 2 will go here, and then at this scenario your j value has become -1, right? And in that case our loop won't run, loop will go away. But you still have one element that is 1 here, right? And then your array has already become 1, 2, 3, sorry, 1, 2, 2, 3, 5, 6. Now even though j is negative, it doesn't matter, we don't have to use any loop to sort the element that is in the noms1 array that is pointing by I, right? I was already in the good position, 1 was already sorted. So in that case we don't want any loop or anything, any extra work. But what happens, we have another different array. Let's see the another example, right? Let's see we have an array like this, which is 4, 5, and 6. And let's say you had in another array like 1, 2, and 3. Now you had 0, 0, and 0 here, right? Now since your I was here, j was here, and then your index was here, like that, same case. But at this time 6 is larger than 3, so 6 will be here, your I will move here, your index will move here, right? Again you will compare 5 with 3. Since 5 is larger, so you will move 5 here, and then you will move your I value here, your j value is still there, it hasn't moved anywhere. Your index value also moved here. Again compare 4 with 3. Again 4 is larger, so 4 will go here, your index will point to 6, and then your I value basically has gone out of bound. Now your I value is basically what? I value is -1, right? In this case your array has already 4, 5, 6, and then last is also 4, 5, 6. Now, if you see it here, j hasn't moved anywhere, right? In the scenario of I, it doesn't matter if I moves anywhere or not. In the particular scenario, when j value becomes zero, but if j value doesn't become zero, if j doesn't move anywhere, it doesn't become negative, we have to use another loop, which basically is like this: while j is still greater than or equal to zero, we will pass our that j value into index nums1 of index is going to be nums2 of j, and then we'll do idx minus minus and then j minus minus, and that will move your 3 here, 2 here, and 1 from there to here. So that's the particular edge case that you have to remember. All right, so let's code this up in the LeetCode and then try to submit it. I think my handwriting got so messy, but I hope you understood the assignment. So I'll try to explain it here in LeetCode too. Initially, you have to assign index value to be m plus n minus 1 to point our index to the last element, and then your I value is going to be m minus 1, integer j value is going to be n minus 1. Now you will loop while I is greater than equals 0, and then j is greater than equals 0. In that scenario, you will check if your norms1 of I value is greater than or equal to norms2 of j value. In that case, the first array's last element is greater than last array's last element, right? In that scenario, you will say norms1 of index is going to be norms1 of I, and then you will immediately move your pointer, both pointer idx and then I minus minus. But if that's not the case, you're pretty sure that the element is basically norms2 of j, and then you will move your index minus minus, and then you will also j minus minus. Now after this loop successfully runs, if your j value is still greater than 0, that means your pointer hasn't moved anywhere, or just moved 1 or 2 but still has some elements remaining which is unsorted. In that scenario, you will say nums1 of idx is going to be nums2 of j, and then you will say idx minus minus and then j minus minus. All right, if you just do this, your whole solution is already good. Now let's try to submit this, and then let's see if it runs or not. Let's run it. Let's see what it says. It says we missed something. If undeclared identify. Okay, noms is not. Oh, we had to say noms1 here. That's my fault. Did I say noms1 to everything else? Okay, I said it. Okay, let's see. Oop, missed something. Semicolon. Please don't forget semicolon in your code. I'm telling you all. All right, let's submit it. It's run now. Woo! So all of the test cases have been submitted successfully. Now let's submit this code. All right, it beats 100% of everyone. So this is the solution that you all were waiting. I hope you all understood something from today's video. And then regarding the time complexity of this code, you can simply say that the time complexity is going to be big O of m plus n, I would say, because or not m plus n, it's big O of, you can say big O of n, right? It's basically linear time complexity. You can check it out. All right, thank you so much. Bye. I'll see you in another video.